Today's topic of discussion is cartilage. Cartilage is non-vascular, but it is surrounded by vascular connective tissue called perichondrium. Nutrients and metabolites enter and leave the cartilage by diffusion through the matrix. Cartilage has all the three components of any other connective tissue, that is the matrix, and embedded within it the cells and fibers. Based on different arrangement of these components, cartilage can be classified into three types: the hyaline, elastic and fibrous cartilage. Hyaline cartilage provides structural and flexible support. It is found in articular cartilage of bones, ends of ribs, nose, larynx, trachea and bronchi. The cartilage cells, which are also called chondrocytes, are placed within hollow cavities called lacunae. In case of hyaline cartilage, the smaller and flatter chondrocytes are located more peripherally in the chondrogenic layer, from which chondroblasts develop to synthesize the cartilage matrix. The matrix is smooth and homogeneous, and interspersed are very fine collagen fibers, which is mainly type 1 collagen, and under light microscope these collagen fibers are hardly visible because they are very thin. Hence the matrix appears glassy and amorphous in hyaline cartilage. A thin layer of perichondrium, as I have already mentioned, surrounds the cartilage. However, hyaline cartilage, when it is present in the articular part of the bones, there the perichondrium is absent. The next category is elastic cartilage, which differs from hyaline cartilage principally by the presence of numerous elastic fibers. Epiglottis is a classical example of elastic cartilage. The cells, which are otherwise called chondrocytes, are present in lacunae just as they are present in hyaline cartilage. They are present in sets of 1 or 2. The smaller and flatter chondrocytes are distributed peripherally as before, and you get to see fine branching elastic fibers dispersed in the matrix. Since these are elastic fibers, they also take the silver stain and may appear blackish. The presence of elastic fibers gives the cartilage flexibility in addition to support. There is a thin layer of perichondrium around this cartilage. And as I have said, that the perichondrium is a type of dense irregular connective tissue. The third one is the fibrous cartilage. Intervertebral disc is a classical example of fibrous cartilage. This type of cartilage exhibits dense collagen fibers. So it takes the hematoxylin eosin stain. Dense bands, parallel bands of collagen fibers are seen with rows of small chondrocytes in the lacunae. The collagen fibers may be so dense that you will hardly decipher the matrix. The size of the chondrocytes remains same even in the periphery. There is generally the absence of perichondrium in case of fibrocartilage. This is because the fibrocartilage generally forms a transitional area between the hyaline cartilage and the tendon or ligament. So, a surrounding covering of perichondrium is not needed here.